Today we're going to first talk about probability and statistics in quality. The learning objectives for this session are to explain the difference between probability and statistics, give an example of measurement and attribute data, and to describe how statistics are used in the field of quality engineering, and finally to list major statistical methods used in quality engineering. So to start with, though, we're going to start this entire section, because it's a long section, with a game. So I'm going to flip a coin, which is a euro. And for every number, every single one of you will receive €1 from me. And I'm going to then flip it again, and for every eagle, you will have to pay me €1. So let's play, and you can tell me when you would stop the game and complain. So first toss, we get a number. So what does that mean? I have to pay every one of you €1. For the second toss, finally, good, an eagle. So now I get to have all my euros back. So I'm going to toss the coin another 8 times. Now, when did you start to complain? We have 10 tosses. There was one time a number, and the rest of the time was an eagle, so I got lots of money back. Why are you complaining? And how can you justify your complaint considering the sample size and the relative frequency of each result? And we will look at exactly this in session 2.3. So, but in general, I would like to talk about probability and statistics. And we're going to use this slide, which came from Professor Argon Chen from National Taiwan University, who gave this lecture to our TUM class here during his visit. What is the difference between probability and statistics? So let's think of a population. This population has characteristics which follow a model. For our game, our population was the coin. It can have either the number or the eagle, so heads or tails. And we know that with a normal coin, the probability of getting a head or a tail is exactly equal. Thus, we have the model for our population. Now, we use probability to infer what we will observe if we take a measurement of our population. And in our example, it'd be if we flip the coin. Thus, probability allows us to infer something about what we would expect to observe in the population. However, when we don't know the model, we use statistics, observations, to infer what the model of our population is. For our coin game, we know that when we flip a coin, on average, half of the time we should get a number, and the other half of the time an eagle. And therefore, we use this knowledge of the model, and we expect for our 10 tosses to have about 5 numbers and about 5 eagles. That's using the knowledge of our model. In this case, the coin we know. But what did we get? We got 1 number and 9 eagles. These were the measured statistics. We also call them statistics. So statistics then tells us that what we observe should let us know what our underlying model is. And I would think in this case, we would say that we do not have a fair coin. Let's look at Taiwanese Big Lotto. Here, you can choose 6 numbers from 49 and expect, in the hopes that you'll win the big prize. So now we've got 4 gentlemen from Taiwan. They like to play the lotto. Mr. Chang chooses numbers randomly, and he never believes in any historical analysis of number appearance. Mr. Fang chooses numbers that most frequently appear in the history. Mr. Wang chooses numbers that most rarely appear in the history. And Mr. Yang chooses meaningful numbers such as the date of his birthday. Now, from these 4 gentlemen, who is correct? Let's look then at the probability of the big lotto game. We have 6 numbers from 49. In this lottery, what is the probability of winning the first prize? The answer is from probability theory. From the knowledge of the model, we know that this is 1 over the number of possible combinations of 49 distinct objects taking 6 at a time. So, is this answer based on probability or statistics? It's based on probability. This is our model. So we get the winning probability. We have that inferred from our model. Now, what are the assumptions behind this answer? Every number has the identical probability to be chosen independently each time. Let's look now at the statistics of Big Lotto. What are the statistics in the Lotto problem? In other words, what numbers do we expect to appear? Again, the answer, statistics is used to estimate the appearance probability of each number. And how would we do this? We would infer the model from the sample, from the observations. So let's go back to Mr. Chang, Mr. Fang, Mr. Wang, and Mr. Yang. Who was correct? Now, Mr. Chang chooses numbers randomly and never believes in any historical analysis of number appearance. What does he believe in? Does he believe in probability or statistics? And here, if you answered probability, be right. Mr. Chang believes in the model. Now, Mr. Fang chooses numbers that most frequently appear in the history. What does he believe in? Does he believe in probability or statistics? He believes in the statistics. He believes that what you observe will then help you infer, predict what will happen in the future. Now, Mr. Wang chooses numbers that most rarely appear in history. He's got an interesting way of thinking about it, but he's also looking at the observations and then drawing a conclusion. Then we have Mr. Yang. He chooses meaningful numbers such as the date of his birthday. And I think we could easily quite say here that he is he's just superstitious. You could also argue that he knows it doesn't make any difference, so he believes in the probability. Okay, one final note. As the well-known statistician George E.P. Box stated in the last century, all models are wrong, but some are useful. And in quality engineering, our models are extremely useful. So thank you very much, and we'll continue to the next section of this lecture.